Today, we are going to prove, without doubt, that it is possible to build an Optimus quickly. We're going to take a look at all the parts that it takes to do that. So this is going to be a little bit of a nerd show. And but then many of us are nerds. So we kind of...
If you're here, you are a nerd already. So
thank you, Scott. This is Scott. He's with us again. Scott Walter, in case for the three of you who don't know who Scott is. And we're going to dig into Optimus even a little bit deeper today and take a look at a project that Scott put together last week because he could. So this is Randy Kirk. Be sure to follow Scott, follow me, hit the like button, join my Patreon, all that kind of stuff, and let's get right into it. So, Scott, what happened?
Well, you asked me a question.
Yeah.
And the question was, how long would it take to put together an Optimus? And we've always thought, it looks like it's going to be pretty easy, but never really put a number on it. And it's not like I've had like a spreadsheet or anything like that to do it. But my gut impression at first, when you asked, it's like, you could probably do it in a day. And then I thought a bit more and I go, right, one guy, morning shift. That really, and then it's like, all right, now let's go through and really see if I'm right on that. And I'm pretty sure. So, I mean, we're going to, make a few assumptions here that it's not like we're coming in with just, aluminum powder and a little bit of iron over here. And we're going to build everything from there. So the servos already exist. So I think we kind of talked about it. It's almost like a kit. Yes.
But the servos are built.
Yes, the servos are built.
But I'm just saying, but they're being built in mass. They're being built. Right. They're all machined. Are cast or what? I don't know. How do you build a servo?
Oh yeah, there's eventually there'll probably be the outer housings will probably be cast and then machined. Right now it looks like they're being completely milled because they're not ramping up to that phase yet. Right. So they're able to produce all those things. So assuming you have all the parts. So the whole idea is it arrives in the mail in a big box and it's completely disassembled. Okay. So some assembly required, and now you have to go through and put it together. So the analogy we're doing is like, is this going to be easier than your IKEA furniture or not? So it's going to come in, you're going to have some tools, you're going to have a little bit of those hex tools and everything else you're going to do on there. And hopefully a good set of instructions that actually details what you're supposed to do.
Not created by IKEA.
But you're not being given an arm or a leg. Right. You're given all the pieces to create an arm and a leg, to get everything together. You're given the FSD computer, you're given the battery pack and everything else. So we'll go through those steps to see why and what's involved and why I'm pretty confident. So if I can figure out how to share the screen.
I have now given you permission. So now
okay. So I have the permission right there, and I'm going to be going over to this screen right here and share, and you should see that now.
Okay.
So a lot of these slides I have, everyone might wonder, where'd you get that? Where'd you get that? All these are coming from the Tesla videos. This one is from AI Day 2. So usually I leave the marker up here. That's why, I didn't cut it off. So if anyone's really interested in finding it, you can go in and look at these presentations. So it's either the Investor Day or AI Day 2, or one of the videos they put out there to recruit for AI. So there's, we'll be looking at some of that. So this one is pretty good because it gives you an idea of what constitutes the Optimus robot. We can see all the servos that are here. We know there's going to be a bot brain, which is and this is what we're assuming this is manufactured offsite somewhere and it comes in. And we'll have produced all these servos that we need. And there's the battery pack. Now, in this part of the presentation, Lizzie mentions that the battery pack is like in the torso. And then she corrects herself and she says, it is the torso. All right. So that's very important for us to realize there's not some torso we put the batteries in. The battery pack is the torso. And this is probably being made in Sparks or somewhere else at the where the Panasonic factory is in Giga, Nevada, because these are 2170s. They're going in there. They have all the electronics and everything sealed in there. So that's going to come in as one sealed unit. So you're not going to have to put that together, but that's now going to be the torso that you build everything around. Okay. And points out the fact that there's 28 actuators, but there's 28 structural actuators, but there's really only 6 different types. So we have a total of 28, which we can see are all the orange bits here. And all the blue bits are a lot of the electronics that are going to be in there. Maybe the control boards that might be controlling one of these specific servos, and of course the FSD computer and everything else. And then these ghosted kind of parts in here are probably some of the structural members. And so we'll look at them to see which is going to be the most complicated and the hardest for someone to be able to put together. And then we have the hands. So the hands might be the most complicated one, but again, I'm going to say, well, just assume that someone puts that together, because I don't know if it's going to be really easy or really hard. It just got lots of little pieces in it and springs and stuff. And it's like, whenever I have to put something together, it's got springs in it, I'm like, whoa, wow, that's, I don't want to deal with that. So we'll have that, but we'll just be able to then pop the hand on there. But we're not going to have completed arms, completed legs, or even completed torso. So what's involved there? And the head might be something that you can pop together as well, or it might kind of come in as a unit. Okay, so we've got that down there. And we go to the next. So I just blew this up to make it a little bit easier to see what's going on. So they give you a little bit more detail so we can see where the servos are. And what I want you to see is that this isn't one servo. This is actually two servos that are mounted at 90 degrees. Same thing here, same thing here, same thing up over here. And as we go through, we're going to see some details of that. So those are the things that you're going to have to start putting together. Okay, so how do we put it together? Well, this is a blow up of that battery pack that was in the upper corner there in that presentation. And this is the best shot I could get of it before it kind of opened up. So when they went to that slide, it exploded open. I was hoping to get it completely sealed, but that's as close as I can get it. And so I'm going to take that pack, and I've sort of rotated here in this image to show it against a couple of the other Optimus images so you can kind of see where it belongs in there. This is the back side of it, and over here, and we have an Optimus there. We can kind of see the ribs that match there. So we know it's sort of in here, and it'll become a bit more obvious in this image here. Now I'm going to take this and stand it up. All right, so we want to see what happens when we stand this image up, and I've now colored some parts of it. So the yellow piece is the back. Okay, this here is what would you call that? It's kind of the collar, not quite the collarbone, but the head is going to be mounted on here, and the shoulders. That's going to be clear. The purple part, that's the front-facing part. And then right here where you see these little blue areas that I marked out, that's where they mount the FSD. So that's kind of where the chest plate and everything else is going to go. And the green bits in here, that's the batteries. All right. So now let's take a look at this image that was also in AI Day 2, where we can begin to get an idea of seeing what's going on here. So this whole chest area, of course, is where the battery pack is, and we could see how the arms are mounted on there. And right here, we can see these are the motors that are parts of the shoulder. So if I pop right there and kind of color code it, that red part that I was talking about before is right here, and the front facing part is right in here. So that there is the whole battery pack. That's your torso. So all you have to do is take this servo and mount it on there. And I'm just going to go between these two so you can again see that. So you see this kind of orangey red bit right here. That refers to this bit right there, just so you can kind of track what's going on.
Got it.
Okay. Now there's another image a bit from the side to give us a better idea. So here we can see there's the torso battery pack. There's the part that sticks up. That's going to be where the head is going to be placed. The head's not in this image, but it gets mounted right on there. And again, we can see the motors that go right on here. So when they create the torso, actually, these motors are going to be part of the torso. They're not going to be part of the arm. And we see that in the arm that's in the Investor Day video, is that this bit is not on there. This bit down here is, but technically this is part of the arm motions, what kind of causes it, but it really forms the torso. Now, down here is that same image that we had before, just to see the lower part, that this is of the torso that's here, gets mounted onto this pelvic girdle, which is where your legs are going to come on here. And it may not be so obvious, but this motor assembly here, which is two motors, it's one that's going down here, that's pinned on there. It's designed to rotate about this pin joint here, but actually then has an axis that goes along here that makes the leg rotate vertically. There's a motor behind it, which we can't see, and over here too. And the same thing here, there's a motor behind there we can't see. These three assemblies are identical. It's just that one of them is flipped 180 degrees up and mounted into this triangle here, and then the battery assembly comes right on top of it. That's it. That's the formation of assembling that. And then your leg, again, when we look at a leg, what we are considering a leg, two of the motors aren't part of the leg assembly. They're already up here. All right. Now, so we can take a look at that. This is what it might look like. This. I don't know if they're actually going to have tools like this or not for being able to do it. It was probably there just to make it easier for the bot to be able to run this particular function. but we get a little bit of an idea of what it looks like opened up. And we're going to be looking over at the shoulder and how everything comes together. So let's kind of break down some of the steps of what happened. So at the beginning of that video, we end up seeing this arm. And we're going to end up getting a close-up down here of what's happening with the arm. So I blow that up so we can see it a little bit better. So here's the arm. And I want you to look over here. This is actually this is the second motor of the arm. Like I said, the other one is actually in the torso and it needs to be mounted on there. And then we can see the rest of everything else here. And so there's a motor here, and then it gets connected onto here with 1, 2, 3, 4 bolts. How hard is that, Randy?
Not even hard for me.
Yeah, I mean, done. And then you have, there's a little bit in here, which is a structure, and there's going to be a motor mounted in there. And I think this here is probably like the plastic housing that goes around it. So that's something that probably pops off and you get something else in there. This motor here and this motor is identical. They are not different motors. They are absolutely the same. And the motors are actually designed to be able to snap together. It's kind of interesting that you would build a motor that way. This one down here is a slightly smaller version of these. And then you come down here and you have the same kind of structure that you're going to put 2 motors on here and a few other things. And we're going to get some close-ups to get an idea of what's going on. So this rotates like that. That motor's designed to rotate this way. The elbow is rotating around here with a servo hidden underneath that cowling. And then we have the roll for the wrist. It actually happens here. And then these motors that are used to make the hand move in pitch and yaw. Okay, so now let's get a little bit of a close-up here of the arm outside. Oops, let's see. Okay, right here. I got to keep my fingers from hitting the scroll bar there. So this is a close-up of the arm on the table, and we can see this motor here. And now we can see it mounted in Optimus when the job is done. Okay, and right now, if you weren't able to tell, you should be able to see that this red motor here is this red motor over here, and this green motor here is that green motor here. And this is a little bit of covering over where it's been mounted. So you can't quite see what's going on there, but we're going to see that in a second. So that's how this gets over into there. Now, again, I just wanted you to be able to see that I highlighted a few features here. So you can see that, oh, this feature here corresponds to that feature. This feature along here kind of corresponds to that. That little purple hole here, I've got over sort of, so you can kind of match everything up. Okay, so let's take a look here that the Optimus that's on the table is missing an arm, and we can see a flange right in here. This bluish area that I've highlighted, and I'm just kind of circling that. So this is where the arm is going to come in. Now this flange is actually attached to the motor back here that we can't see, and I'm hoping we'll be able to see it when we get a close-up right here. Okay, so right in here, this is the shoulder motor for the shoulder roll that's attached to the battery pack. And this flange is attached to the motor in the part that it rotates. So that sticks out, and we now need to mount the arm into the flange. So we can sort of see it coming together here. Now you look at this little piece here. What do you think that little piece is?
The connector?
That silver piece right in the middle.
The connector? No.
No. Okay, so I've highlighted little things here. The blue part here is the flange. We have the red motor here. We have the green motor here. I've got kind of the purple motor here. And again, this is sort of part of that, but it's a spinny part of this thing here, which is fixed. And that silver part right in the middle, what do you think is the purpose of that?
You keep asking, and I still don't know.
I mean, a lot of times you look at it, so it's attached to the motor, so clearly it must be an axle, right?
Yeah.
No, it's not. It's a poka-yoke.
What?
It's basically, it's not actually part of the motor. It's not part of the motor design. It's a cap that they pop on there to make sure it's easy for Optimus to pop it in. It's just so inserting that into the hole is a lot easier. It's there to line up the holes, to help you line up the holes. That's it. So you can see here, there's 8 holes in here, and they're threaded holes behind here. And this is the mechanical interface between this flange and the motor behind it. And the whole idea of this connection is that when this motor here rotates, the outer part of that motor moves and the inner part stays fixed to this flange.
Okay.
So if we go back a little bit to this here, a lot of times when you look at a motor, you just imagine a little axle that comes out and that's the whole part that rotates. No, 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 no. You see that green arc there? I should make that a big full circle. That whole bit rotates. The entire bit. That's your mechanical interface right there. This serves absolutely no purpose. And it's actually, if you look at the motor designs, and I think when we get down one of them, we'll look at it, it's not in any of them. It's not there. So it's probably just a temporary thing that they popped in just to line up the holes when you decide to create the mechanical interface. So you just put in 8 bolts to lock it in. Okay. Now, the interesting thing about this is that this is coming in from behind. Rather curious, right? Because you might be assuming that, oh, there must be a flange behind there. And we're going to see whether that's the case here. So, okay, I highlighted some of these things here to make sure you could see the different colors and identify the different sections. But if you look here, we get very few views of Optimus from behind. It's really rare we get anything. So this is like the closest. It's a little bit fuzzy, but I'm looking around here to see these motors, and I do not, this is like the back end of the motor, and I don't see anything else in either of these two shots that indicates to me that there is another plate back there or another flange that mounts to.
Okay.
Okay. So again, I'm highlighting the different parts. So that's the mounting flange here, and that's the motor itself that we can see in both of those. Okay. We go back to AI Day 2, and this is Bumble C coming out, the bot that walked for the first time without a harness. And we can see up here at the top, this is the bot moving towards us. And the bottom one is the bot moving away from us. So this is the back of the bot, and this is the front of the bot. And we can sort of see that they already are thinking very much. I'm really surprised at how close this is to their final kind of idea. There's some little design changes, but they really already were thinking of certain things and how they're going to be done. And they've kind of stuck to it. And again, these motors to me look like they were not off the shelf. These are the ones they may have had to already make. Oh, okay. You know, an early prototype with some of them. But if you look here, you can see that there's a flange that it's mounted here on the front side, and there's also one kind of in the back side. So the motor is in 2 places. And if you look at it, when the bot puts the arm up, you're able to get a view when it rotates. You can see that motor that's in there and this flange here. So you see that kind of C right in there. Yep. That's connected to that motor, which means it's mechanically attached on both ends. The current design, it's not. It's only on one side. And that's sort of interesting because it means, whoa, it's mechanically, it's more cantilevered as opposed to being stabilized on both sides. So it's a little bit heftier over here, but it's easier to assemble. Got it. Yeah. You just come in from behind and you just pop it in. So again, it's like, if they really were thinking of having humans do it, they a little fork that you would put it in, but you know, so you come in like that, but now they got rid of it. So you kind of come in this way with it because it might be easier for Optimus to put together. Wow. And it's rather interesting to see them evolve the design that way and that decision. And it may have been a little bit cheaper, but that flange that you have on there is able to handle some of the torques you're going to get on there. So, and then now here, I brought this up because again, I wanted to highlight, you see the motors down here on the legs? Yep. You could see those were off the shelf. You know, it's like they were just trying to see what they can get and they go, holy cow. You know, it's like, they're really, you know, we can't find what we want. They're kind of close, but they're not quite where we want. So it was enough for them to be able to get this project up and going. But it seemed to me that these here may have been very early prototypes of the servos that they came up with on their own. Got it. Yeah. And this here was just to get, so this is just another image to kind of show us what the backside is. It's the closest I've had of a backside, but it's in an animation. And part of the reason I put it up here is that the first thing everyone's going to say is like, oh, what's that right up there on the neck? Okay. What's that bit? Is that the charge port? Oh, because we keep on wondering, is that where the charge port is? Is that where the charge port is? And I was like, actually not. You know what it is? Huh. It's the kill switch. The kill switch. or let's call it the e-stop. Okay. So if you'll notice that right on the very back of Bumble C, there was an e-stop. Now, what's interesting is that some of the other videos they showed, evidently there was a Bumble B and a Bumble C. And some of the things that they're showing in the video, and you can tell because Bumble B, whatever the material is they use for the neck is black as opposed to silvery, and does not have the e-stop in the back, if any. So they probably realize, hey, you know, we're going to need an e-stop for this, aren't we? Usually you'd want to make sure there's some way of being able to stop it. So yeah, that's where you have to go. Now, if we look at what's going on here with the legs, the lower legs, we can see a little bit of the pelvis up there. Again, we can see those two motors mounted at 90 degrees to each other. Very easy to put together. That whole pelvic girdle, I think, is like really easy to put together. You're going to have a couple of wires that you snap in here and there. That's not going to be tough to do. And then probably the most complex part is going to be, I would think, the thigh, or the femur section, the upper leg. Get on down here, and we can see a little bit. So we can sort of see the insides of this a little bit, and that it's a bit more mechanically intricate, but still nothing that's hard to put together. So that's what would be the most challenging. The lower part won't be that bad either. So we kind of go in here, we can take a look at the lower part and say, all right, so you get the foot, there's not much there. You got a couple of little pin joints that are probably very easy to put in. At most, you just kind of tap it through, and then you're going to have something that you probably just tighten. I don't think you need to press fit it or anything like that. It's probably just going to go in there with a hex nut or something like that, and that's more than enough. Do you see anything here that looks like it would be a real challenge to put together? Because this is the whole assembly right there.
Yeah.
You get that servo, you pop it in that axis there, then you go down here, they get pressed in. I don't think it would be that hard.
Yeah.
The lower part. And then we move to the upper part here. Oh, so here's like some actual physical footage of the real thing. But again, this is the prototype of the latest version. So this is not Bumble C. This is like right after Bumble C, where they're already playing around with it. And again, you can see, it doesn't look like it would be that hard to put together. I'm looking at this. It's like, oh, is that a hex head there? And that, to be able to make this assemble, that's pretty easy to put together. And so we have a slightly better look here. Again, an early prototype, because the pelvic girdle has changed a little bit. The most complicated thing about this is just all the wiring.
Yeah.
And as far as the manufacturing, this here looks like they probably just machined it. So I think they probably just CNC machined to make that. I'm not quite sure the lower part where this cast. It's rather interesting. You see this here?
Yep.
I don't know. Did they weld that together and buff it, or did it come out of a casting and they had some flashing they needed to remove because someone was really aggressive with the sandpaper or whatever, or the grinder going through there. And then, you see these parts here, like, oh, 3D printed. There's nothing here that looks like it would be hard to manufacture, and really not that difficult to probably pop together and put together. And I think it's probably a one-person job. I'm not even sure you need two people to do a lot of this.
Right.
Yeah. And so again, this is an early prototype. You can see something made out of an aluminum billet on a CNC machine just to kind of test it out on the hand. But again, there's not going to be anything super sophisticated. So this is probably the most mechanically intricate part right there. And again, I think it's just, this is the one that takes, I don't know, 90 minutes or something like that, or now that's the one that takes the most time to probably pop them in. But once you have the procedure, I don't think it's that hard. And then you connect everything together. You might have a couple of fixtures or jigs to sort of hold things in alignment the way you need, or kind of hold it in a certain place. And then you just kind of pop it in and you're done. And then we can see that then attaches to the pelvic girdle right there, and you're done. Again, the left and right leg are the same. They're just the leg, and the arms are just the arms. And you just have a left and right hand that you pop on there. And we can see this mechanism. I don't see anything that tricky in the mechanism. There's nothing that's going to be that hard to put together. And if you worked in your garage, you've seen things like this in your garage, right? Crankshafts and stuff like that.
Sure.
And how hard were they for you to be able to take apart and put back together?
You don't want to ask me. I'm the worst mechanic ever, but
yeah, me too. But
eventually not that hard.
Yeah, but for the motorheads that are out there that would say, we see something like this under our hood all the time. Sure. You probably say, yeah, that's not that hard. And you just kind of go in and, you knock the pin out, you do something else, you bring it in there, tighten it up, give it a little bit of lube, whatever, and you're done. So and then, it'd just be running some wires through there. But at that point, they'll probably have figured out the whole harnessing system and what's the ideal way to run everything. And,
Sure.
and everything will just be coming right on in, snap, and you're done. And again, here's the motors. Here's what they look like. And so do you see an axle coming through any one of them?
No. Mm-mm.
And this is the one we're talking about up in the shoulder. It's not there, but we can see that whole sort of copper colored part. That's the part that rotates.
Mm-hmm. Mm-hmm.
So this is designed because they knew that they're going to be using it as a mounting flange. So you wanted to make sure that, okay, you've got, you're basically the bigger the mounting flange, the more mechanical stability you're going to have there, as opposed to trying to tie into an axle, which is going to slip, and you've got the pin that you got to kind of put in there, rotate. Well, this is much better. So they eliminated actually a lot of parts from what you would expect when I look at it, because they design these things to kind of plug together. They design the motors to have exactly what they needed for that and not more.
Mm-hmm.
So there's definitely some advantages. And now here's some pictures. And this is from this recruiting video they had that was like about 2 minutes long. And this is I think pretty old. It probably goes back to summer, just showing them like, let's put together a servo. So like, these are the pieces that you need. All right. Got a couple of bearings here and there, a couple of things that they probably had to make in the shop themselves, on a turning machine or something like that.
Right,
They've got a couple of circuit boards that evidently they can make themselves because, they're able to. So it's like coming up with these boards, it's not like it's that big a deal. They just buy the chips and then make them however they want. So again, that's something I think they're doing in-house. There we go, putting it together, standard wrench, nothing really special. Put it on there. Look at this thing here. Like I say, from IKEA, probably. And if you look at this, eventually this will probably be a cast part that's then machined on the inside. Just turn to the inside to make sure it's good. And these holes, but this is probably coming from like an aluminum billet, and they just run it on a CNC machine right now. So it takes a little bit of time to do that, but it's not like it takes forever.
Right.
How long do you think it would for a CNC to knock out that part? What would you guess?
You're asking the wrong guy. I've watched it being done, but I have no idea. But not very long.
Oh yeah, I think under an hour. I mean, it might be that it's like 20 minutes or something like that, because there's not a whole lot of material that's being removed, and it's aluminum, which is really easy.
Right.
Really, really easy, and I think you could do that just with a very simple billet. And there are other ways to manufacture faster to kind of get something close to the shape you want, and you do the final machining.
Right.
So again, a close-up of that, how hard does that look to manufacture? I mean, these windings here are probably the hardest thing to do, but I think they've got probably some equipment that already makes things like that. Again, looks like it would not be that hard to manufacture. This here is showing the inside. I'm assuming it's copper or brass or something like that. I don't know if it's for connectivity reasons or because it's a bit harder than aluminum.
Mm-hmm.
And I'm thinking it's because you don't want the threads to strip.
Mm-hmm.
So if you need to have a certain amount of loading on it, you would probably decide to go with that. And the reason I'm thinking that they're making it out of a different material is if we go back just a little bit to here, this is the one that only produces 20 newtons of torque. And they're showing it silver, almost like, that's probably made out of aluminum, because that's okay. It can be made out of something light and soft. But up here, because we're going to be delivering like 5 times more,
right,
5.5 times more, and up there, we might make it out of some slightly sturdier stuff to be able to handle it. It doesn't have to be stainless steel or anything like that hard, but probably something a little bit more. And okay, so I think these are just showing all the different types of actuators. Right. That's actually like everything I think I had, believe it or not. Did I do that in record time?
In record time.
Any slides you'd like me to go back? So your impression is, how hard would it be to put the bot together?
That was my first thought when I was trying to, because again, I'm trying to imagine how hard is it to get from here to there? How hard is it to get from a prototype, as Elon likes to say, prototypes are easy, production is hard, but how hard is it really in this particular case to go from a prototype to production? And so again, because I do have experience in manufacturing, I started thinking, okay, they got some plastic parts and some metal parts. They got some motors, actuators. They've got these various, but those are known issues. These are things that have been built before. It's just a matter of building them the exact way they want them, or buying them off the shelf if they can buy them off the shelf. So all of those specific parts get lined up like an IKEA project or like a Lego project. You lay them all out. And now how long does it take to put all that together? My first guess in my head was maybe 3 man days. And then that's when I said, no, I know the guy to ask. so I hit you up and you said, no,
it's pretty easy. And it's a question when they do it. It's quite common in a manufacturing environment for them to do something called kitting.
Yeah.
Which is very inefficient, because somewhere off on the side, you've got people who are taking all the pieces you need and laying them out. So the analogy is that when you go in the dentist's office and you're going to have a procedure in there, the assistant comes in with a tray with all the pieces that the dentist is going to need for that. They're already kind of laid out.
Right.
But, they had to go over and get that stuff together. So everything you need for that particular operation. It's the same way the assembly line works, is that when an operator has to put something together, rather than having buckets of all these things that they have to kind of grab for this and that, they literally are given a kit. Now, they don't have to unbox it, hopefully.
Right.
But it comes in, it's been laid out maybe on a pallet, which means somewhere else someone is grabbing all the stuff and getting it in there just to make sure they can meet the cycle time. But in a sense, there's like all this other stuff. There's a real question: is there any value add in that? As opposed to just sort of having it there to grab it. So if you're trying to make it efficient, there are arguments on why you want to do kitting. And sometimes the kitting is not done actually in the factory. It might be done way back at the supplier.
Yeah.
So that's kind of crazy. So really they are making these little IKEA kits that you send off, and then they sort of show up on the production line and all right, take this stuff out, everything I need, put it together. Yep, the next one. Yeah. So they could be doing that. But the other thing I'm thinking more about this is that Elon keeps on saying prototypes are easy, production is hard. All right. So do you think he just accepts that as a fact? That's just how it is. Prototypes are easy. That damn production is just always going to be hard. Or do you think they finally said, you know what? We want to really figure out how to do production. So we think about how we produce the thing and we create the prototype from that, because Optimus looks too easy to put together for what this is. I mean, really, if you go to a think tank and say you got to put together something that does it, they won't even be thinking at all about production. This is so easy to put together. It just occurred to me that we're kind of looking at the Gen 3 platform in a way, from the philosophical standpoint, that they really thought, let's screw this whole idea of production being hard. Production will be easy.
Because
now design the prototype to make sure the production is easy. So it's like, wow, I think that's where they're going.
But I think Elon might also be seeing this from the standpoint of somebody who builds rockets and cars. Mm-hmm. And if you build a rocket or a car, it goes really, really fast, really fast, and it can hurt somebody if things don't go well. And so your precision, everything goes up in terms of precision. Everything goes up in terms of fit. Everything goes up in terms of testing. Everything goes up in terms of regulatory agencies that you have to deal with. So I think that would impact what he's talking about. But if you're talking about this robot, which is going slow, which has a low likelihood of hurting anybody, which does not have the amount of precision that these other things would require in terms of the product being made or in the fitting together, I think all of a sudden production may not be quite as hard by comparison to the
prototype. But what see, when he keeps on saying prototypes are easy, production is hard, what is he saying? The production ramp is very hard.
Yes.
So you're able to get the prototype out there and you're able to produce a few more. And then we say, all right, let's get our production line up. And then you're having an anemic, 50 vehicles a month coming off the line and all kinds of problems with the ramp up. And it takes you, 18 months, 2 years, takes a long time to get up there. And this is what all the EV startups are finding out. Yep. This is what the OEMs are discovering. And so I think they said there will no longer be a ramp up because your water bottle does not have a ramp up, does it, Randy?
No, it doesn't.
When they get all of the equipment in Giga, Mexico, they're going to just turn it on and they're going to be coming out.
I hope you're right. It's one more of those.
They are. It's occurred to me now that they probably have. That's the whole reason for the unboxing process. It's the whole idea for everything. This is probably why Franz is just like, oh, I really want to tell you what it's like, but I can't. Because they're sitting on something that is just going to be coming out so fast. I mean, they're going to be literally printing these things almost, it seems to me.
Well,
they're stamping them out. Boom, boom, they're just coming off the line.
And there's an entire cadre of the Twitter, Elon, Tesla fan base out there that believes that the Tesla Cybertruck is where the unboxed concept started, and that it will be unboxed.
Yes, it could have been, and I've kind of heard that back and forth whether it is, and I believe there is a quote that they said that they're going to do it. Yeah. And it's just, I think what happened is the way the Cybertruck was designed. It just, the only way to put it together was in kind of an unboxing. It just naturally was that way. Right. Because of the way the side panels and everything else came in.
Right.
And maybe they've been thinking about this process also in another way, or they looked at it and said, can we do this for the normal? What's keeping us from being able to do it with the Y or the 3? What is the differences between it? But it probably aligned itself up because it looks like it is something that's just meant to snap together. You don't have to build the whole body in white.
Yeah. And then you and I speculated the other day, for those who didn't see it, Scott and I speculated the other day that they might have stopped production, stopped everything with regard to the semi-truck, and redone it for unboxing.
Yeah, maybe. And then I had some people in Twitter Spaces kind of push back a little bit and say, well, the production volume's not quite there, and it has to be made in assembly line because the way trucks are built, because of the way the truck frame is. It's like building a ship, it's like you got to put down the keel and then everything else kind of comes to top. So maybe that it doesn't go to the perfect unboxing method, but you never know. There may be some aspects of it that they're working out and putting in there. Either that, or it's like it's done because Optimus is doing that work. I don't know. But I'm thinking more of these different strawberries that are out there and looking at the Berlin video and people saying, oh, it could do this and that. Think about some of the operations that are going on in the final assembly. And a couple of them are the frunk and the under trunk. I mean, what are those? They're just these plastic bins that just kind of get dropped in and popped in really easy. And there's someone's doing it. And of course, the person that's doing that has got 3 or 4 other tasks that they have to do around there that may require a bit more dexterity. But I would not be surprised if they just start saying, okay, we're going to have this task. We'll just let Optimus do it. And he's got to get used to working around everyone else. And everyone's got to get used to working around it. So it'll probably just go over and go up to the trunk and boop, drop it in, all done, and maybe push something down and just get out of the way. So it's possible there's going to, I can now easily imagine my 500 bots if they decide to go there. But it might be that it's that's a step too far. Some of these things that are, they're too easy. The fruit have already been picked at this point.
No.
Right?
See, that's where I slap back and I say, no, the reason why you're going to build that 500 to 1,000 bots, not necessarily just because it's this wisest place to place them or because it's a perfect solution in terms of taking out the human. No, it's because you want the data. You want the data.
Yep.
Lots of data.
Yes. Yeah. And you want to see what it's like to interact with humans as well. So, it's possible to do that, but that's going to be a management call and everything else.
Sure. As we said before, this is going to be an exciting 6 months or so to see exactly what comes out of all of the things that Tesla has introduced us to just in the last 28 days, much less the last 15.
Well, not just the last 28 days, it's caused us to do analysis of all the information they've been giving us in the past that we looked at it and didn't realize that, wow, there's a tidbit. So there's still more stuff in that silly Investor Days video that I'll be discussing with John in another video. He vaguely knows of that already, that we've already kind of talked about it. So it's like, when he has time, because, he's hard to track down.
Well, Scott, I want to thank you again. And for those of you who have missed them, you need to go back and see the 2 videos that John and Scott and I did the last couple of days this week, as well as the week before. There's a whole series. If you're interested in the whole robot thing, just look up any video that Scott has been in, or John has been in, or I have been in with regard to Optimus. Put those all together and you will have a book. You will have hours and hours and hours of really concentrated and deep information about what we speculate from what we're seeing that Tesla is showing us is happening out there. So once again, follow Scott on Twitter, follow me on Twitter, follow this channel, like it and subscribe and hit the notify button. And then definitely I'm looking for more folks to join Patreon. So thank you again, Scott.
Thank you, Randy.
Thank you all of you for watching. And as usual, it's been great talking to you.
Click the link below to get your paperback, Kindle, or audiobook now.